She tells us how to work it out, and then she gives us a sheet telling us different problems. And we just go off in pairs or something and work it out.
And when they've worked it out, pupils at Eleanor Palmer Primary School in North London get well above average results in maths. Over 4 programmes, we're looking at how they teach mathematics across Key Stage 2.
We are going to start with some maths mentions. Jason and Cecily.
Head teacher and maths coordinator Kate Frood has a great personal enthusiasm for maths. Here she's celebrating pupils' achievements with special maths mentions in assembly.
And the other one is for somebody who's really learned that you've got to have a go. You've just got to try, because if you don't try, nothing will happen.
Clearly, if the head teacher is into something, whether it's computers or environmental, sustainable development or maths, the school develops a flavour and perhaps an expertise. So there's no doubting that I bring to headship a particular experience and passion for primary maths. I have to say, got a B at O-level, and that was the end of my personal maths, which is probably something to do with how I was taught at secondary compared to how I was taught at primary, which I think was my inspiration. So yes, I think the staff know that Kate loves maths and it's her baby, and I think they're more apprehensive about an observation in maths than they might be in literacy, but I also hear them say, but I always learn masses.
Tell me something about the number 12. Don't put your hands up. Share your ideas, what you'd say about the number 12.
Once a week, head teacher Kate Frood teaches Year 5. This lesson is about solving number problems.
6 times table, 8 times table. It's a factor of 24 and 48. Yes, it's not happy. And 96. I know.
Okay, so what now can you tell me about the number 12 that's really impressive? Hands up. Jamie.
Well, it's a factor of 144.
It is indeed. They join knowing their tables, and I kind of see my mission, come Top Juniors, is about using and applying them and realising that if they know those core facts, they just know so much else, and it unlocks so many other things. So if you know your 4 times table, you know your 40 times table, you can spot factors, etc. So I sort of have a whole programme of really just flooding them with all that mental agility, knowing factors, primes, multiples, squares, square roots, triangular numbers, everything about numbers. Very much pure maths for a term.
The next task is to use the clues on the card to work out what unique number they all refer to.
Bigger than 50. And it's 2 digits. Okay, so what's all the square numbers above 50?
And also, 5 times 15 is 75.
The 5th number is smaller than the 15th multiple of 5. What's that? What's 15th multiple of 5? 75.
The number is larger than 2 possible numbers. That's pointless.
Right, let's try them out again. The sum of the digits is even. Yeah.
It means the number we're looking for, Lawrence.
One group has help from a teaching assistant.
6. Right. 3 to 3.
Could be 33.
What I want to know before I reveal the answers, which clues were the most useful? Okay, Esme.
I think in our group, the 2 clues that were most useful were that the number is bigger than 50, but less than the 15th multiple of the 5.
Which was?
75.
So straight away you could narrow it down to between 50 and 75. Okay. What else was useful, Isla?
At the beginning, it wasn't really useful, but it was a clue. It is the highest of 2 possible numbers, and at the beginning it really wasn't useful because we didn't know 3 possible numbers, but at the end that's what made us guess it.
Brilliant. Okay. Any other clues that weren't very helpful? What wasn't very helpful? Tamim?
It's between 1 and 99.
I agree, actually. It was a bit broad that way, wasn't it? Yeah. But at least you knew it wasn't in the thousands. Okay, the moment of truth. Are you ready? If you had a little number 1 or an A on your envelope, your number, drum roll, 42? Yeah? You got it? Well done. It's almost indefinable. You just get this sense that suddenly a child has got numbers and they can just see all the patterns and all the connections. And at that point, they're off and they can cope with the Top Junior curriculum. But I see no point in doing ratio, fractions, perimeter, all those other things until they've got that inside out, back to front understanding of times tables. What we've got here is a multiplication square. These are the answers, but the questions are missing. These are the answers that have to be put into the shaded bits so that the products make sense. 3 is one of my choices. I reckon 3 probably goes there. What do you reckon? Could 3 go there?
No.
Why not, Gemma?
Because
Help her out, Kate.
55 isn't in the 3 times table.
What else isn't in the 3 times table? Add on.
20.
20 isn't a multiple of 3, is it? So it can't be a 3 there. We've got to choose one of these numbers, which is a factor of 20 and 55. Come on, Gemma.
5.
You think it could be 5. Why are you so sure?
20 and 5 are in the 5 times table.
20 and 55 are in the 5 times. Okay, so if you were right, Gemma, what would go there?
11.
Brilliant. And what would go there, Gemma?
2.
Okay, see how these things sort of unwrap? Some of you are going to have a go at working through these. For some people, I'm going to make it a little bit more complicated. Now, oh yes, one of the numbers has to appear twice. If you think you've got a suggestion about what might be used twice, put your hand up. What number might be needed twice? Alfie?
2.
Okay, tell me why you think you're going to use 2 twice.
Because it's a useful number for all of them, apart from 27 and 15.
Brilliant, it's a factor, it's useful, you use 2 a lot. You could have 2 and 12 there, couldn't you? Good suggestion. Any other suggestions which number might be 12? Lulu?
7.
Ooh, why 7?
Because it's the only one that fits with 49.
Oh, okay, if you look at the 49, and that's your choices, I think she's right. The only way of making 49 would be 7 times 7. And can I tell you something, Lulu? It's the right answer. Give her a clap. Excellent. Good girl. I know it was a team effort. It was a team effort. Well done. By about now, they can actually just apply all that knowledge and work quite quickly to cut through to kind of to narrow down what it is they need to be finding rather than just being at sea. So it was kind of, for me, it was almost like an assessment lesson, like has this now bedded in so that they've got that confidence to apply it?
So they start work on the product squares, one more difficult than the other.
Yeah, and 5 times 4 is 20.
Yep.
And 11 times 3 is... 3 times 11 is 30. 4 goes here, 7 goes here, 11 goes here, 3 goes here.
The higher ability group have an even more testing task.
We've got to use numbers 1 to 9. What you've got to do is you've got to have 5 times 9 times 1 is 45. So, and then something times 5 times something is 160.
4, 3, 2 is done by 8, 9 and 6. And 70 is done by 7, 2 and 5.
And there's support for those who need it.
12 times 8.
It is. So shall we try that one there?
Yeah.
2 times 4 is 8. 5 times 4 is 20. What number are we going to put here and here now?
7 times 5 and 5. 7. We can't use 5 twice.
2 times 11 is 22. 3 times 11 is...
33.
So do you want to fill that number in? There you go. You can write.
There are, there's 3 statement children in this class, so obviously different expectations there, complex needs. And I think what we've identified right now, very early on in Year 5, is the group who are going to need the extra work to get the 4. But there's a group in this class functioning at level 5 already, I'd say, because the gloves are off and they've been able to play with numbers and go off the path quite early on, rather than a sort of a unit in Year 6 where they're taught to problem solve. It runs right through the school. Anyone do any of the harder numbers now? Yo! Because of course this is from Year 9, so come on. Let's ask Lulu.
I know where 9 goes.
Where does 9 go?
It goes next to on the right of the 2.
You're absolutely right. Why are you so sure it goes there and not there?
Because 1 and 8 is 9.
Because that's a multiple of 9, isn't it? So we can do this, surely. 5 9s are 45. How many 45s in 315?
7.
Brilliant. Now we've got to take a gamble, everybody. We've got 6 and 8 left. Can we do it?
7.
It's tough, that. There's nothing to really give us a lead, is there? Go on, Jamie, have a go.
I think the 6 goes on the left of the 2.
Right. If he's right, we just do the multiplications now. So, 6 2s are 9 12s are... We did it! Give yourselves a pat on the back. Fantastic. What's definitely improved at this point is a lot more confidence, a lot more enthusiasm, I think. And one of the things that I think is misunderstood, or perhaps I just don't agree with in some maths quarters, is this notion that problem solving has to be something rather ethereal and open-ended constantly. And I'm a great believer that what really motivates children is almost a sort of closed problem. Today, there was a definite right answer, there was a definite end point, and that sense of satisfaction and joy of having done it and solved it is terrifically motivating. Whereas I think if you ask kids to investigate patterns generated by, a pattern of paving stones, actually you've got to be quite sophisticated to get pleasure out of that. So we do a lot of these there are 12 ways, can you find them all? Or can you fit all the numbers into this grid so that... And that's very motivating.
At Eleanor Palmer School, games are a popular learning aid. This is a lunchtime card school where Year 5 pupils teach the Year 2s how to play.
Are we allowed to lay out our cards? No, you can't let the other person see it. Can I do for me too? Okay, right, now I get it because I'm the second one to play the ace. Thank you. And then I start. Okay, we'll remember in future you have 6.
Joe, you've got 6.
Okay.
And Dylan, you've got 5.
So,
What do the pupils get out of these sessions?
I would say it's more the social context of working with young children, teaching them the rules, giving instructions and the responsibility, but looking at how they can teach the maths to the younger children. Because it's obviously quite simple to them, but they can see that the younger ones find it quite hard.
Lorna is 11 plus 6. Rosa, what's 8 add 6? 8 plus 6. Count on 6. 8, 9...
9, 10, 11, 12, 13, 14. If that's your card, Rosa, then how much have you got? No. 14. Can I add up 17? 17, well done. 17, and now if you have 4, how much have you got? 17, 18, 19, 20, 21.
How does the head teacher know that the school's approach to teaching maths works for her pupils?
I think they can talk about maths and they associate it with fun and problem solving and with being with their friends and interactive teaching, and not something which is about ticks and crosses and failure and boringness. So I think the measure of any success in a school is the clients, isn't it? And I think the children have a confidence, I think the parents have a confidence that the school does it well. And our results are good.